Well, Peter, thank you so much for helping with my project. Could you say a little bit about yourself?
Uh, my name is Pete Swan. I've done space stuff for 50 some years. I've built spacecraft. I've operated spacecraft. I've taught spacecraft design. I just love space. And we are going to the moon. I'm just getting that out front. We are going to the moon and we're going soon. So I'm excited to be here talking to you.
Can you talk about some of the spacecraft you helped with?
Well, the first 20 years I was in the Air Force, most of that's kind of quiet, so I don't talk about that. But I then did 10 years with Motorola and we did the Iridium Constellation. So we launched 92 satellites that were all identical, all smallish compared to those days. Nowadays, not even close. But anyway, and so we provided a cell phone anyplace, anytime for Motorola and its team, and it was a tremendous engineering success, as evidenced by we're into the second generation now. We designed a good lesson that you have to learn in space is that you design spacecraft for the harsh launch. Once you get into space, then it's really a benign environment, assuming you design it for vacuum and temperature changes and all that kind of stuff. But it's a very benign environment. So our satellites that were designed for 5 years lasted 20 plus. And that's a lesson that people don't take to heart, that it's the rocket launch that's the hard part. After you get up in space, of course, it's a harsh environment, but we designed for it. And so we can operate in space relatively easily, and it's not that much of a problem. Now, I'm not saying you don't have to worry about radiation, you don't have to worry about solar energy and heat and all that kind of stuff. But we know how to do that. So that's what I did for 10 years. And then we taught, I was part of a 4-person ownership team of a company called Teaching Science and Technology Incorporated. And we went around and taught how to build spacecraft. And we taught it at all the locations you could figure, the NASA sites, the Air Force locations, but also Boeing, Lockheed, and a whole bunch of other contractors, that they would bring in new people and recognize that our education system really didn't teach space. They taught electrical engineering, they taught mechanical engineering, but they didn't really teach how bad a rocket launch is or what the harsh environment in space is. So we came in and taught people how to design spacecraft to be in that type of environment. We even taught at the NASA Astronaut Center. That's a hard one to get around. We are a bunch of spacecraft people designing, robotic spacecraft, but they wanted us to talk to them. So, of course, we went and talked to them.
Yeah, it's amazing to think about inside that payload fairing, all the acoustic dampening that's
Oh,
inside just to try to protect the satellite from the trauma of launch, as you were talking about.
yeah, literally, if you're outside, on top of a rocket, outside of it, when it launches, the acoustic wave is so great it could kill you. I mean, humans are kind of fragile, so we try to make sure we're not in the wrong places around launch sites.
It's kind of interesting. I was hearing or reading something about the the proposal to send a probe to Juno, I think. No, not Juno, but to one of Jupiter's moons, and it has to. It's the something Clipper. What was it called?
Oh, yeah, yeah, whatever it is, I've forgotten.
But anyway, it's supposed to be on a SLS rocket, and I was hearing recently that uh, there's an evaluation are done to see if it could actually survive being launched on SLS, and maybe they need to launch it someplace else. And I was just wondering, how do we protect our astronauts if it's so difficult for equipment? It seems like astronauts would be more fragile.
Well, one of the beautiful things occurred recently. They published, or they have a movie called First Man, and it has Neil Armstrong's story going to the moon. And when you watch it, you're really amazed at the reality in the human shake, rattle, and roll at the initial liftoff. And you remember the days, well, you weren't there, but in the 60s when they were actually doing that, it was amazing that we had designed a vehicle to take people and go through that whole environment. And the truth is, we've done a very good job. The SpaceX new Dragon vehicles, the Boeing vehicle that's coming on, the Orion, we've taken into account the hazards that are inherent in launch, and we've designed for it. So the design engineers are the ones you have to thank, because they accepted the fact that it's a harsh environment, and then you work it out. I'd like to make a statement early on. Rockets are necessary. We must have rockets. We've got to have rockets. However, my whole passion nowadays is to make sure that people understand there's rockets, and there's another alternative that's come up recently. Space elevators can be done today. It's a bold statement, but the only thing that's been holding us up in the past has been a material to work in the space environment. And now we have that. There's a new material called single crystal graphene, a sister material called white graphene, and 6 other materials that are capable of providing a tether long enough and strong enough to do space elevators. So what we really have to do is ask the questions you've been asking about how harsh the environment is during launch, and consider having an alternative. And so I'm putting out a paper now in another venue that says we need an appropriate architecture to go to Mars. We need one that's based on rockets, the future rockets like Starship, and it's based on space elevators as a permanent infrastructure that provides a routine, daily, inexpensive, no shake, rattle, and roll, safe approach to adding energy to a body, so that when it gets up to the proper location, it can go into orbit. Now, there are a lot of downsides with space elevators. The principal one is it's not there yet. So if we want to go to the moon in 2024 or 2025 or 2026, I mean, near term, I'm convinced we're going, and I'm convinced it's going to be in that time period. Then we're going to have to go with people on rockets. And I don't have any worries whatsoever that our design engineers are going to do a fantastic job on the SLS. SLS will do it. The Elon Musk space or Starship vehicle will do it. Jeff Bezos' new vehicles will be right in there in the mix. So we will have people going to the moon in the near future, and space elevators can't be ready for that. So there's no real issue there. But if you're really believing that we're, as a humanity, are going to move off planet, and of course, first step is the moon. I've been saying that for a long time. What we need to do is go practice on the moon. It's 3 days away. That's a lot better than 9 months. And so we need to practice on the moon and learn all the stuff we can. And then we need to go to Mars. Now, 2030, 2040, somewhere out in there, we're going to go to Mars. Mr. Musk wants to go earlier. And he's a surprising gentleman that achieves what he wants to do. So it wouldn't surprise me if we go in the early 30s with Mr. Musk. So he's got great vision. Jeff Bezos has great vision. NASA, Mr. Bridenstine has great vision, and I'm a supporter of all of those people. But I just asked the silly question, now that we have the capability to build space elevators and provide a logistic support infrastructure, why not have a dual path? Have rockets to take people through the radiation belt rapidly, which is a very big thing. We got to get through the Van Allen belts fast. And so rockets are superb at that. Rockets are available today. So let's start our exploration with rockets. But it takes a while to build a railroad to space. So we've got to start. We've got to start laying the track. We've got to start that. And that's not a trivial exercise. And we need to kick that off. So we should have an appropriate architecture to go to the moon and Mars. In my belief, it ought to be rockets and space elevators.
What do you think about the idea of first building a space elevator on the moon? And you don't have to worry about all these constellations of satellites. Something goes wrong with it, you don't have like the geopolitical people impacts. And I understand that it'd be simpler since it'd be instead of having kind of like a counterweight that's in like geosynchronous orbit or lunar synchronous orbit, it would actually be based upon the you know kind of like the end of it being beyond the liberation point between the Earth and the Moon.
Okay, just for background, I wrote a paper on which should be first, Mars, Moon, or Earth space elevator. So I have some credibility. I actually started studying space elevators in 1984. I didn't have a clue what I was doing, and I didn't publish anything, but I wrote a paper on the Lunar Elevator in 1984. And I've loved the Lunar Elevator ever since. But what I've come to a conclusion is that if you can build an Earth space elevator, you should do that. You must do that. And the rationale is that rockets are not going to provide a big avenue to the moon. It's going to be periodic launches with a few people each launch. So the demand for transportation in the cislunar area is small in numbers. It's large in importance and large of critical step in human history, but it's small in numbers. So there's no demand for a space elevator that's going to come into the equator of the moon. It's got to go to the equator of the moon, and we're going to put all the people at the South Pole. At least that's the current plan. So then you have to take a cable, and you got to go from the lunar equator down to the South Pole and have a cable car. So there's no reason why you can't do that. Jerome Pearson proposed that in a paper in 78 or something like that. I mean, way, way, way back. The lunar elevators is an essential step in the development of cislunar space. And I applaud people like Michael Lane, and then the university back east, I've forgotten who it was, said they have to have one that's 200,000 kilometers long or something. It turns out you have to have a longer one in lunar orbit than you do in Earth's orbit, but that all has to do with dynamics. But my principal point in the discussion between Earth and lunar orbit is demand pull. Who needs it? It's a nice thing to think about, but who really wants a lunar elevator? Well, when we get a space elevator on the Earth that's launching daily and doing 5,000 metric tons a year to the moon, then you're going to need some place to catch that stuff. Instead of using rockets at the other end, we need a lunar elevator. So we believe the lunar elevator is essential. It's essential in the cislunar transportation infrastructure. But you ain't going to have any demand until you have a lot of people going back and forth. And rockets are a principal means of doing that, but they have their limitations, like number of launches and stuff like that. So got to have the Earth one first. And then you do the moon, and then you do Mars. And so space elevators are essential elements of the transportation infrastructure.
Could you talk about the challenges and technology required to keep the space elevator from colliding with things in orbit, especially as we're creating...
Like space debris. Let's use the word space debris. There's a bunch of junk up there. Okay, let's first start with credibility. I tracked space debris for a year in the Air Force when I was in the Air Force. So I then have been keeping up with it and have done multiple papers on space debris at international conferences. And I have worked with the Space Debris Office in Houston for NASA. So now, not lately, it's historic, but I have worked with it and I understand the topic. Two things you have to understand. First is, it's a huge space up there. The volume up there is unflippin' believable. Just to get a feel for it, most humans can understand the volume around their home and the size of their city. So they can pretty well tell if they can get to grandma's house in 10 minutes or an hour. But if you really ask them how far Disneyland is or how far Disney World is, they start talking in airline miles and airline time. And then you say, okay, how about if I go to Dubai or someplace like that? And they're just shaking their heads because it's an overnight flight and it's forever. And that's just the volume of at the surface of the Earth. Now, if you go up in volumetric is radius cubed. So it's going up real fast. So when you go up to low Earth orbit, let's just say, 400 or 500 kilometers up where the space station is, it is so huge, it's unbelievable. And the number of space debris is large. So there are probabilities of conjunction. So what we did is we had a guy who spent 20 years in the Air Force and 10 years at Motorola studying space debris and collisions with other aspects. And he predicted the collision that occurred between an Iridium satellite and a piece of junk. And he said, we've got 100 satellites up there. It'll happen once every 10 years. And so he actually did the numbers and showed that with a methodology and a mathematics model that has been approved by NASA down in Houston and used by the Air Force and all that kind of stuff. So we then, the guy named Skip Penny and I then took the volume of space and took our 1 meter wide tether that goes straight up and did a probability calculation for the collisions between junk in space. And when I say junk in space, I'm talking operational satellites and everything else. Small stuff, big stuff, everything. So we did a calculation on the conjunction of one piece and the tether. And we did it for 2010, which is when we did the calculations. Well, in the last year, I redid those calculations for 2020. I took all the numbers that NASA gave out, actually 2019, but they gave me numbers for 2019. And then while I'm doing that, they published the numbers for 2030. Because of all these new constellations, everybody kept asking, well, what's going to happen when we put up all those Elon Musk constellations and all that stuff? Well, NASA did a calculation for 2030. How many pieces of stuff will be in orbit in 2030? So what we did is we took the same methodology we did in 2010 and did it for the density in 2020 and the density in 2030. The answer came out that it's a manageable problem, that we can plan for it. We actually have in our architectural design, we have a chief architect handling the design of the space elevator. In the architectural design, we have what we call an adjunct system, which is how do we deal with space debris? So let's take an action, let's put it in pieces. How often would there be a potential conjunction? If you have all the little itty bitty parts, like less than 5 centimeters in size that we don't track, there's a lot of those up there, they're going to hit each 1 kilometer segment 10 times a year, once a year, something like that. I've forgotten the exact number, but they'll hit it each year. So what we're going to do is we're going to design the tether to take the hit of small stuff. So you have a woven tether, and if one piece of the woven aspect is hit, we'll have the other strands absorb the extra tension. So we actually have designs of the space tether that would be able to handle the periodic penetrations. And then we have an adjunct part, which is a fixing of the tether. So we'd have a tether climber going up and down looking for holes and patch it. So we've got the little small stuff as a passive acceptance of the hits and then an active fixing. Then we go to the larger stuff. Well, the larger stuff we track. So by the time we become operational, we're going to have a robust artificial intelligence approach to where all the debris is and projecting 24, 48, 72 hours ahead on where it would be. And so we would project the potential conjunction between stuff and the space elevator all the way along. Now, we're only really concerned about the first 2,000 kilometers. Everything else is trivial. low probability. So we would then take multiple approaches to the problem. The first one is multiple strands. What we plan on doing is at 2,000 kilometers altitude, or 25, nobody's figured it out yet, run 6 strands down instead of 1. So if one is cut, we still have continuity. And it turns out that the probability of impact above 2,000 kilometers is almost 0, because there's nothing really up there. And so probabilistically, and in addition, we've got more volume as you go up, right? So you get 2,000, you got a lot of volume more. So we're not worried about 2,000. So we put 6 tethers down, 1 gets cut, we use the other 5. And so that's one approach, that's a passive approach. Then we have the active approach. If we project, let's say, a big thing like the space station, having a potential conjunction, then we move out of the way. And the way we move out of the way is we move the base station, it's a floating platform, or we reel in or reel out from the base station, the Earth port, or we have a tethered climber going up and down and we can just stop it, go up faster, go down faster. All those motions instill reaction of the tether dynamics. So the tether dynamics change just like a piano wire. And so the sinusoidal approach of the tether would move an element of the tether out of the way of a potential conjunction. And that's all calculated, and simulations have been done and shown you can do that. So we have both passive and active manners to deal with space debris. And our feeling is that space debris is a manageable problem and will be part of the design for the future space elevators.
I was just thinking about sort of, you know, it's kind of some confidence building and intermediate steps that could be done that might be cheaper, but would help get closer there. And I was wondering, in terms of maybe creating something, you know, a tether that was used with like high altitude balloons and had like a kind of a cable car that went up and down it. I mean, that could be, it seems like something that would be reasonable to do, and could almost be self-funding from the amusement aspect of it.
Yes. The preliminary steps from, let's say we get approval to go forward with the program and somebody with money actually gives us some money, there are going to be engineering validation steps along the way. And one of them that's very real is, you know, 100 or a 40 kilometer altitude balloon that holds up something, and you go up and down and show that you've got the tether climber and the tether material that works. And so whether it's 40 kilometers long or 1 kilometer long, or floating in a thing, or hanging from a bridge, whatever we need to do to prove to the investors that this actually works will be done. I also believe we'll have to take the next step, which is in-orbit proof. And not a small tether satellite like we've done in the past, which, by the way, have been very successful and working fine. What we would want to do is have a major step that people would say, that shows that space elevators will work. And so I'm thinking, now this is all preliminary. We have no idea whether we're going to do it or not. It has to do with the engineering teams looking for validation testing to show the investors so that they'll go forward. And one idea you could do is 1,000 kilometers of the material you're going to use. So we got to wait till the material's ready. Then 1,000 kilometers centered at 2,500 kilometer altitude. So basically you run down 500 to 2,000 and up to 3,000. That's in the radiation belt. So there are no satellites in that arena. You know, there might be a few pieces of debris, but the probability of intersection are almost 0. And so you're 1,000 kilometers long, flying in orbit, and then you would show that you could actually move tethers up, tether climbers up and down, and you would show the dynamics of the tether at 1,000 kilometers that would reflect our space elevator pretty well. You could validate your simulation methods. You could validate the climber tether interface activities. You could validate your software at Ops Center to show that you're actually having control of your tether and everything else. And then you could, at the end, you reel it up and you have it in a single satellite. You can either deorbit it or put it in a permanent orbit or something. But we believe that there's going to be validation testing, and whether it's hanging from a bridge, hanging from a tether, or actually in orbit, we must do validation testing showing that the concept works. Now, the engineering side of me says, yes, we can do that. I have no worries whatsoever. I believe the space elevator is doable today. We've got the material in the laboratory. It's going to take a while for that to get to the point where it can be made long enough and strong enough, but it has been shown to be strong enough, and it has been shown to be processed. They have produced single crystal graphene at a rate of 1 meter per minute. So they actually are producing it out of a process. Now, that material isn't as strong as we need. The material that was shown to be as strong as we need is only a half meter long, but we've got long enough and strong enough, just not together yet. We'll get there, but you know, that's just the development of a new material, and it just takes time for that to happen.
Now, graphene is just another form of carbon. What would it take to actually take the carbon out of the air and kind of build it on the spot?
Yes, I don't know. It turns out that carbon is a very big element, and we can definitely use that. I've been jokingly saying for the last 5 years that we should get a carbon offset for all the carbon we'll be using in the tether. So we should be getting funding from the government for a carbon offset for sure.
I just imagine a future where skyscrapers are actually assembled from materials out of the atmosphere. You know, you don't actually, they kind of grow just like plants.
Well, the idea is that this new material is called two-dimensional material. This new material that was Nobel Prize was awarded in 2010 for is a two-dimensional molecule that's atom to atom. And when you put carbon atoms in there and grow it longitudinally, it's a carbon bond, a little bit stronger than diamonds. So you literally are growing it from a vapor deposition type thing. So it is coming from the atmosphere. You're going to have I'm trying to remember what the process is. I think it's methane, but I could be wrong. But anyway, you put in a gas at a very, very high temperature, and the carbon atoms combine into a crystalline structure, and then you pull it out. And it's the strongest material ever. I just saw a chart on it that says stronger than steel by 200. It's the most conductive material ever. It's got the best resistance if you put it in the other direction, so you can have no conductivity. It's got the best rip protection of any material, so it's the hardest to rip. It's a miracle material that's going to be used for a lot of things. So I have great confidence the crystal graphene is going to be built because it's so phenomenal for just terrestrial uses. It'll be used in bridges, and you won't have these big, humongous cables. They'll be like 1/100th the size of the cables, but be able to handle it. So I mean, it's a phenomenal material.
It'd be so thin that people would be afraid to go on the bridge, and they have to put something cosmetic on the outside just to give people confidence.
Oh, I don't doubt that. Yeah, the remarkable material is there, and it should be interesting to see it develop over the next little while.
It almost sounds like we should use it for power transmission as well, instead of.
Oh yeah. It's a phenomenal conductor, the best ever, and so it really is a remarkable material that's just taking off. And you know, we need it for space elevators, but so many other people need it also.
Yeah, I mean, the more uses we find for it, the more investment and you know, building out that infrastructure to create it and mold it
Yeah,
and use it and
yeah,
repair it.
yeah. And the real kicker is develop the manufacturing of it. Yeah, so it's really an exciting point to be today. I was talking with a member of my board of directors yesterday, and we were talking about we're at a pivot point in history where we've got the momentum going toward the moon and Mars, and we're going to have a vector that's, you know, kind of like going in that direction. And it's pretty big time with NASA's belief they're going to put women on the moon, women boots on the moon. And we've got Elon Musk saying he's going to get a Japanese tourist going around the moon in the next year or two. And then Mr. Musk saying he's going to put a colony on Mars. And we've got NASA saying they're going to put a little, NASA in Europe put a lunar village up there. And so there's a vector that's starting to really go off planet. And if that's not encouraged and supported and pushed in this new direction, the pivot might be in the wrong direction, and then we'll wait another 50 years. And that would really be sad, because I was in that crowd in the Apollo days, really expecting to get to Mars by 1980. And then everything kind of like slowed down and went into stall, and let's go to low Earth orbit. That was so exciting. And so we kind of had a pivot point in 1969, 72 time period, and it went in the wrong direction. So I think we're there now. I think we're at a pivot point, and we need to have that vector toward the moon reinvigorated by Mr. Bridenstine and his movement toward movement boots on the moon. I think is really remarkable.
And you know, I think back to like the 1960s and 70s, or at least what I know of it. I really depended
You know, it's
upon
history books for you.
history books and movies and stuff like that. I have the fortune of being born in the same year as Mr. Bridenstine. We both missed the last lunar landing by 3 years. We're both born in 75. Um, but you know, just what I've learned back then, and if any of this is wrong, please let me know, is pretty much we only had two competitors, you know, the US and the USSR. But you know, now we really have the United States, we really have China. It's unclear on exactly Russia's capacity for exploration at this point, but you know, they still are, you know, they still have some capabilities. Um, and you know, you have Europe, and you have a lot of other countries that are really getting there, as well as private enterprise, Blue Origin and SpaceX, and uh, you know, 15 companies as part of the commercial lunar payload services program, two of which are landing probes on the moon next year. I mean, it seems like there's a lot more of a surge now than there was in the 1960s, and it seems like that might make it more likely to happen, or at least take more for it to peter out. I was wondering if you had more confidence.
Yes, I'm confident. Of course, I'm an optimist. I've always been an optimist. That's why I always work on the front end of the new technologies, because I'm an optimist. I know we can make it work. But I believe, just like you said, that the momentum is really pretty large. And it really is exciting to see the momentum toward the moon. As you mentioned, you know, we've got international cooperation. We've got, I'm going to move to the other room a little bit because the noise is going to start. We've got our long guys here. But the real kicker is that we have a tremendous amount of energy going that direction. We really need it to continue. So we're looking forward to it. And my wife and I have been space geeks forever. So we love this whole thing. And it turns out that I believe it's going to happen. And it's far more than just governments. It's, as you said, the international is really big time. Oh, that was okay. Yeah, the international is really remarkable. And a friend of mine, John Mankins and Giuseppe Ribaldi, are both in charge of the Moon Village. And this is a concept that's being pushed by a private organization that says we really need to create a lunar village. And then along with that, creating a lunar village, we've got to come up with policies and legal and sociological and psychological, and then architectural aspects like what color we're going to have the rooms. You know, that's not even talking about how the engineering is and how we do all that stuff. So the enthusiasm is really pretty neat.
Yeah, talking about all those other things, there's a lot of investment into transportation, but it seems like there's almost not nearly as much in terms of habitation and kind of testing those living systems. And it seems like that is in the realm of really small groups of people and individuals to kind of put together ideas for habitats, build out examples in like with budgets of a few tens of thousands or hundreds of thousands of dollars, and actually test them out by having people live in them and then just kind of iterate over a whole bunch of different designs. Um, and I don't know of anything like that going on. I was wondering if you had heard of anything.
Well, there's multiple activities across the community on um, building habitats. And they even have gone so far as having, you know, one out in the desert in Utah, and of course the Antarctica living facilities are a good example of how to live in a harsh environment. So we're learning a lot from there. I think the real question is, how do we get into the lava tubes? Everybody keeps talking about building these pretty little things on top of the surface and having made in space, what do you call it, computer
Like
manufacturing.
3D printing.
Yeah, 3D printing of habitats and stuff like that. But, you know, we really have a problem on the surface of the moon, and that is called radiation. So there's been a large push lately to understand the lava tubes. And they came up with a statement that there's a lava tube on Mars that's big enough to hold the city of Philadelphia. And so when we go to Mars, we ought to go visit that and first start living there before we go on the surface of Mars, because they have the same radiation problem. On the moon, there are a lot of lava tubes also. So what we need to do is make sure that we design our habitats to be insertable in lava tubes and blow up. You know, I mean, literally just pump up the outside so that it's a nice little container, and then you live inside of a nice bubble. Because if you use the lava tube as the shield from the radiation, then living is relatively simple. It's an intriguing concept, but there are a lot of people studying and a lot of people looking at it. In fact, I just saw a webinar yesterday or the day before or something like that on architectural aspects of the lunar habitat. And so they were talking about all the important things like, you know, fluid flow, like bathrooms, as well as color of the arrangements and how big do you need the rooms, how many people per room. And then there's a 1/6 gravity versus the full gravity. So do you really have to have the rooms taller so that when you walk, you don't run into the ceiling? They've got some really good people looking at that. So I think that it's mostly academic right now. But if we're serious about going in 2024, they're going to get serious about, you know, surviving on the surface very soon. And more than just a lander, you know, they'll start going to the next step after the first few landers. They'll say, well, we want to stick around for 2 weeks during the daytime. I'm not sure we're ready yet for nighttime, but a 2-week station on the south of the moon, South Pole would be good. And we could end up building habitats for 2-week stays, and that would be a good first step. So yeah, I'm really enthused by the great breadth of activities across the US and Europe, looking at how we're going to go to the moon. And of course, that's the first step. We go there, we prove we can do that, and then we build on to the next step. So,
And I guess, you know, the SLS has yet to do a single test flight, and the first flight of it keeps getting pushed out. And it doesn't, you know, I think Jim Bridenstine and Doug Lavero and now Kathy have really, you know, kind of accelerated the program really. And then of course what SpaceX is doing, I think, is putting a lot of pressure on them. And of course, you know, Mike Pence saying, you know, if these contractors aren't up to it, we'll switch to some that are. But at the same token, you know, we do have the commercial Crew Dragon that was able to launch astronauts at the International Space Station. And there was that op-ed some weeks back about potentially using that to send astronauts around the moon. I was wondering if you thought that was something worth looking further into, or if you had any thoughts on that.
well, Elon Musk has already stated that he's going to send a Japanese billionaire around the moon and accepted the contract and has that in the plan. So let's just put that aside. That's a commercial venture, not in the program plan for NASA and their activities. I want to support NASA. They have done a tremendous job over the last 70 years, and they're really, really very good. Their choice of SLS will be a good vehicle. The future, when they have really started talking about commercial implementation, their commercial supplies to the space station, their commercial humans to the space station, the commercial contract to land something on the moon. They've had a very, very good transition toward more and more commercial. So I really applaud NASA for all that kind of stuff. Their choice of SLS is historic, and they're staying with it. You know, there's lots of choices in the future. Who knows what curveball is going to come along and disturb the NASA plan. But the one reality is that anytime you have huge programs, there are hiccups along the road, and we just have to take the hiccups and keep charging. So my answer is NASA's really, really doing well, and I really am impressed with their leadership around the globe on the Artemis Accords, because they really are standing up and saying that it's important that we go, you know, as America and as a part of a team with Europe and a part of a team with Japan. And of course, Canada's right there with the Canadian Army. They're one of our best partners. So it's important that we go, but at the same time, we set standards. We establish the role that people play in space and how they should work with everybody else. It's not, let's just go put boots on the moon and come home. It's let's go establish humans in space, humans on the moon. Let's establish, you know, all the aspects of American philosophy as well, so that humans have the rights that they deserve when they get there. So NASA's doing a great job in my mind. They're just forgetting to bring along space elevators, that's all.
Yes, no, I mean they are doing amazing things. I mean the Mars 2020 rover and the rovers before that, and you know the commercial crew program, the commercial lunar payload services program, and on and on and on. But if you had the opportunity to go to space, assuming it was safe and affordable, is that something that you would be interested in personally doing?
Can I go tomorrow? I'm ready.
You're ready?
My wife and I have talked about it often. I keep saying that I'm going to do one of those little up and down trips, suborbital, but they got to get the price down to the cost of a Ford Explorer. And then what I'll do is I'll keep my Explorer for 20 years instead of 10. And I just won't buy the second one, you know. But if they get the price down to be competitive and at a reasonable price, then Kathy and I would love to go and experience that. But yeah, if we can get going, I mean, there's all kinds of aspects of spaceflight. Number one is, you know, your body stretches out and all that pain for us old guys, you know, lower back and knees, all that goes away. You know, so, I mean, going into space is really a boon. I don't know why NASA hasn't hired a bunch of old astronauts, because they benefit more than the young astronauts for these flights.
Well, was John Glenn the oldest person to go into space? I mean, he went whenever he was in his healthy time, and you know, later on, whenever I think he was what in his 50s or 60s.
Yeah, he's got to. Yeah, he's got to be the oldest one. Yeah.
I I wonder if there's any research done on him that might really highlight those points. I mean, he would have been in a perfect position to talk about young versus old.
Yes. I am sure that there are people that have studied that. Does NASA care? No. NASA has their astronauts, and they pick them for what they are, which is young, healthy, athletic, smart, you know, the full range from doctors to engineers to pilots to scientists. You know, they've selected their astronauts, and they love their astronauts. And I can't argue at all that they have, you know, the best astronauts that they've ever chosen in the past. But as I'm old, I keep thinking of the advantages of being old and doing this. It would be a lot easier.
Oh, well, I mean, assuming you had the space elevator and not a rocket.
Oh yeah, well space elevators will have no shake, rattle, and roll, and the acceleration is relatively small. And so, but it would take a week to get to GEO and 2 weeks to get to the apex anchor. So we'd have to have radiation hardening and stuff like that. So literally our plan is to do the initial operating capability robotics only first. And we'd have like a 20 metric ton climber, so it'd be 14 metric tons of payload. We'd have one a day. Then the Japanese proposed a system back in 2012, 2013 that would focus on people. And they're thinking of 100 metric ton climbers, which has radiation shielding for people. And they've got it all set up. And they really believe that they need 100 metric tons climbers for two reasons. One is people, and the other is space solar power, because they really need space solar power in Japan. They don't have any inherent energy sources in their country, so electricity from space, perfect for them. So their initial design of the space elevator had a bigger tether climber. Now, as an engineer, they did all the stuff they need to do. Like instead of having a single tether, they're having two tethers, so they have redundancy for safety for people. Their tether requirements are more than ours, but you know that's because they've got a bigger tether climber. Both doable by single crystal graphene, so they're both doable today. Their design of the space tethered climber is more robust. They want it for bigger payloads. They want it for people, so they got to have the oxygen and temperature control and radiation protection and all that. So their robust design is more exciting than ours. Take people on the space elevator, but in addition to being more robust and everything, it's going to take longer to get there. So our organization has come up with the estimate of 2035, 2036 for robotics, and then upgrading to a more mature tether infrastructure might take 10 years, maybe 2045 or so. So we don't have any real concerns about people going on the space elevator. It's just a process. It'll take a little bit longer to get to the full up capability of a human qualified space elevator. But there's no reason why you can't do humans on the space elevator. There's no real shake, rattle, and roll. The radiation protection is just standard for any spacecraft, and you would just go straight up for a week to GEO and 2 weeks to the apex anchor. Now, once you get to the apex anchor, you can be released from there and get to Mars in 61 days. Right now it's 7 months, but we can really go fast and we can cut the corner and get there in like 61 days, optimized. There are many trips that take longer than that, but when the planets line up, we can get there in 61 days. The other thing is we can launch every day toward Mars. Right now they wait 26 months to have a little short window to launch. We can do it every day. and we can do massive payloads. So our studies that we just completed with Arizona State University show that we can get there fast, move a lot of mass, and launch every day toward Mars, which is revolutionary if you're thinking about let's go to Mars. And it's just an amazing discovery that we did in the research with ASU.
Now, when you said space solar power, it triggered two thoughts, which I thought would be worth running past you. One is there's always been a challenge of how to get the power down to Earth, and we talk about beaming, but it seems like while it looks promising, there's still a lot of unknowns there on how effective the power transfer could be. But the graphene you said was highly conductive. It seems like that would be another potential way to get the power to Earth.
Actually, you're very insightful. It turns out that that thought has been brought forward. Very embryonic, very, very early in the thinking, not even early in the research, early in the conceptual development. We don't know what the problems would be like moving that amount of power over a tether. That, as soon as we get the first tethers to be experimentally shown in laboratories in length, so you can put a lot of voltage over it, we can start looking at that. But that could be, I don't want to be aggressive or anything. It's the discussion is going on that area. Now, I believe that the space solar power is probably the most important program that's out there today, and we really need to get it moving. It turns out we're doing a study, the International Space Elevator Consortium, a little advertisement, isic.org. Anyway, we're doing a study that we've got about 4 months under our belt in, and we've got another 8 or 12 to do on the environmental benefits of space elevators. So the obvious one is we don't have any thrusting burning of carbon in the atmosphere. We don't leave residual stages in low Earth orbit. So, the obvious one is we're a little bit better at the environmental aspect than rockets are. But the real important thing is the missions we can enable. If we can get 170,000 metric tons to GEO each year, which would be the mature, like the Japanese version, if we can get 150,000 plus to geosynchronous, then the space solar power becomes possible in the near term after we start. It turns out that John Mankins, the guy who's running the space solar power research, has stated that he needs 5 million metric tons at geosynchronous to eliminate hundreds of coal plants. So he literally is stating that he wants to get rid of the CO2 problem. And his statement has been, we're not going to help the CO2 problem. We're going to stop the CO2 problem. His statement is that space-based solar power will turn global warming around. And it's a powerful statement to make. And so he says, okay, we need this mass up there. And to have 10 to 12% of the population electrical demand by 2060, he needs 5 million metric tons. Now, let's just do a little inverse math. If you launch a vehicle from the pad, only 2% of the mass gets to geosynchronous. So if he needs 5 million metric tons, and you equate that to the mass on the pad, that's 50 times 5, that's, wait a minute, I gotta do this, 5 million, so 50 times 5, 250 million metric tons on the pad to satisfy John Mankin's requirement at geosynchronous. And rockets can't do that. Now they might be able to finagle and do some other things, but they can't provide 5 million metric tons to GEO. Now, John can lower his requirements because all he's got is rockets. There are a lot of things, a lot of ways to do it, and we need to have some near-term proof tests, so we need to use rockets to do that. But the only real way to have a robust space based solar power program is to use Space Elevator. And we show that in our latest study report that we just completed on our website. It's a free PDF download, and it shows how we would satisfy John Mankin's needs for geosynchronous mass.
And
And
did you
it's
say 5 million tons?
5 million tons.
And is a million tons the same as a megaton?
No, megaton's a million. A kiloton is 1,000 tons. A megaton is 10 to the 6 tons. Yeah. Oh, no. Shoot. I'll tell you, I get in trouble all the time with this particular terminology. Megaton is not the same as a million tons, I don't think. I get confused. The conversion between British and whatever, it's 5 times 10 to the 6. So it's a lot.
Because
Yeah.
Elon's talking about, I think each one of the starships would be able to carry 100 tons to orbit. And I think, he's talking about being able to develop a factory in Boca Chica, Texas, that would be able to produce 2 starships a week, and each one would be able to fly like 3 times a day. And so he's thinking in like orders of magnitude different than anything that's been done so far.
Yes. And I believe Mr. Musk can achieve a lot. He can do a lot. It still goes back to the rocket equation. And the rocket equation says you can get 4% to low Earth orbit. And then you can get total of 2% of the mass of the pad to geosynchronous. So if you want to use the rocket equation to get things to space, it's going to cost you a heck of a lot of mass. Now, the rocket equation does not have it in that equation. It doesn't have a factor for cost or for reusability of elements. All it says is to get to the velocity you need to get into orbit, it consumes or throws away all this equipment and everything before it gets to the orbit. And that's 96% it throws away. Now you can reuse it and do all that stuff so it gets cheaper and more reliable and more effective, but it still takes 96% of the mass at the pad to get to orbit. And so the rocket equation is a bear. It really eats you up. And that's the advantage of the space elevator. People have always kind of blown off space elevators because we didn't have a material. Now that we have a material, they have to start recognizing that the space elevator can actually do the job a lot more effectively. Now, Mr. Musk achieves what he says he's going to do. So I have great hopes for him and his Martian colony. But if I understand the numbers right, he wants to launch 3 rockets a day over the 2 years, 26 months. Now, you got to realize that he has the first rocket to put the vehicle up in space. Then he has to launch 3 more refueling rockets so that first rocket can get to Mars. So that's 4 launches to get 1 vehicle to Mars. Then let's say he stores that 1 vehicle in low Earth orbit over the 26 months. So he can do, let's just say it's 3 per day to get the simple math. So that's 365, 760. Let make it 800 days. Okay. So he has 800 days. He has 3 launches a day. That's 2,400 launches in that time period. But he's only sending 1/4 of those. So he's sending 400 vehicles to Mars. They're all launching in 45 days. So let's say that's a launch. I'm sorry, not a launch. Insertion into Martian orbit in trajectory. That's a bunch a day. If you got 400 or so going, and you got 45 days, that's 10 a day. So he's inserting into the Martian trajectory 10 a day. And then, of course, you're landing 10 a day at the other end. You know, roughly it's all the same. Yeah, and so that those numbers are awesome. If that's what he's planning on doing, that blows my mind about the scheduling and, you know, and all the rest of that stuff. But you got to remember, he's got to have 3 vehicles to supply 1 vehicle to go to Mars. And by the way, I'm using 3 graciously. He's also said 3 to 6 sometimes. But anyway, so let's just say he said 400 at 100 metric tons. So that's 400, no, it's 40,000 metric tons. So how many years does it take to get to 1 million? He said he needs 1 million tons on Mars. So 40,000 times 25, right?
25, yeah. But it's really that, you know, every, you know, 26 months. So
Right. He
even,
only launched 26 months.
yeah.
Yeah, he's got big numbers to achieve what he wants to do. Can he do it? Well, Mr. Musk achieves a lot. So I have confidence he'll be able to. I have confidence Mr. Musk can have a colony, and he will have a colony. Okay, I don't doubt that at all. He will have a colony on Mars. My suggestion to him is, let's send people on your ships. But if you want to send a hammer, why don't we send a hammer by space elevator? But by the way, I can launch every day toward Mars. Now, some trips are 400 days, some are 61. So on the 400 days, I'll send hammers and batteries, you know, stuff like that. And then on the 61 days, I'll send pizza and beer, you know, and stuff like that that needs to get there soon. So I can supply him 900,000 of the 1 million metric tons, and then he supplies the people. And that, I think, is an architecture that's appropriate for Mars. Actually, I'm trying to publish a paper called Appropriate Architecture for Mars. You send people on the rockets, you send equipment and support on the space elevator. Seems logical to me. I don't understand why people want to send all that mass to Mars if you've got another approach. By the rocket equation. The rocket equation is a bummer. It just is no better than just a straight bummer. We got to beat the rocket equation. Anyway,
Definitely.
bottom line is, I know we're going to the moon, and I know we're going to Mars. The only question about Mars is Elon Musk going to jump in front of everybody else? You know, I think the answer is tending to be, yeah, I think he is. So it's going to be interesting to see how all this works out.
Um, so not everybody knows we're going to the moon. I've conducted about 250 plus interviews at this point. I have 1,588 more to do. Who's counting? And
Yeah.
uh, and of those 250 some odd, I would say only about 50 of them knew that we were going to the moon. And what do you think it would take to change that, to make it more well known?
I don't know. I fail miserably at 2 or 3 things. One is advertising and marketing, and the other is fundraising. So I have no idea how to improve that. I understand where you're coming from. I teach at what's called OLLI. You know what OLLI is? OSHA Lifelong Learning.
I
It,
don't. Tell me
it's
more.
an organization that's around the U.S. at like 350 campuses. What they do is they combine with a local university, like I teach at ASU. And what we do is we teach people over 50. You have to be 50. You can't join it until you're 50. And it costs you like $50 for a year, and then like $20 for a class or something. I mean, it's insignificant cost. But we have lessons on all the topics that you can think about: art, history, Vietnam War. I mean, whatever anybody's interested in, they can provide a professor from the university or a local retired person or somebody to teach. And so they've got to be over 50, and it's insignificant cost. And the courses are on all topics. And what I've taught over the last 4 or 5 years is, how are we moving off planet? And we've got a core of about 50 students. They don't all come to every class, but you know, about 50 plus students that come to every class that I have, and they're all excited about it. But you're right. If you look at the whole classroom set up in Arizona for this organization, OLLI, most of it's on political, and of course lately it's on a lot of issues on diversity and stuff like that. And the classes are the full spectrum of human involvement. So they're really quite interesting and quite intriguing. And my little contribution is a little itty bitty contribution, but it's only to a few people. And so I believe you're right. If you really look around and ask people, are we going to the moon? They'll say, are we? You know, they're so focused.
Yeah, I've gotten several responses. Some people have said, didn't they shut down the whole space program, you know, because they're thinking about the shuttle? And I've also gotten some other responses. Another thing is, well, isn't that where the astronauts go? You know, the idea of them going to an orbital platform that isn't actually anywhere, you know, it's just going around the Earth is really difficult to imagine.
Yeah, permanent presence in space is not a concept that most people understand. And the ability of us to have permanent presence there is remarkable. And the Russians are part of it, and other nations are part of it. It's a remarkable achievement in the human history. Now, whether we're going to grow up and take a big step is still out to be judged. And you're right, the majority of the people you interview probably don't know that we have a plan to go back to the moon. And if you ask the Europeans, it's not back to the moon. It's we're going to the moon. So you can't use the term back because they didn't go the first time. And that's a sensitive part. So Mr. Bridenstine and Vice President Pence have started using the term we're going forward to the moon because they've gotten feedback from our partners that, oh, you can't use the word back. We didn't go, so why? It's not going back. We're your partner. We're going forward to the moon. So, you know, the whole terminology of going to the moon and everything is really remarkable. And I truly feel like it's going to happen this time. That we really are going, and I believe it's going to happen. And it's going to be more than just boots on the moon. It's going to be more than just putting female boots on the moon and then saying we've done that, we quit. It's going to be a significant movement. Now, will it be aggressive, or will it be once a year, or will it be, first 2 or 3 trips, just putting boots there and bringing them back, or will we actually have a colony on there in the Moon Village? And who knows? Us optimists have great hopes, but then there's reality jumps in and it kicks us in the butt every once in a while. But I truly believe we're going back to the moon. Are we going to make it by 2024? I hope so, but you know, first off, rockets never launch on time. Okay, we launch when we're ready. So it's the same thing about landing on the moon. We're going to land when we're ready. And the year is actually insignificant so long as it's close. I mean, we wouldn't want to say, okay, we're going to land in 32. That wouldn't work. But if we miss 2024 by a year or so, I don't think it'll make much difference. The key is that we make it. The key is we keep charging. But I really, truly believe we're going this time.
I sure hope so. How do we keep going? You know, what do we need to do in order to keep charging?
Well, that's a puzzle. I think that's NASA leadership issue, and at the presidential level, and we can't make any guesses now because November is coming up. But it's a national leadership issue. That's what it boils down to. It's no less than national leadership. Is it important to the U.S. to go? Is it important for the U.S. to be a leader in the international thing? I believe this international approach is the right answer, and really, really invigorating, and I feel good about it. And the international cooperation is significant. We must do that. And our European partners really want to go, I believe. They also have the same issues of funding and everything else that we do, but they see a major statement in their progress, engineering, philosophical, human, international agreement, all that kind of stuff. They see that as being validated by us stepping on the moon. So I think they're going with us. The Canadians are obviously with us. Japanese are always with us. They're very important partners. I'm not blowing them off just because they're very, very, very important partners, and we need to have that. So I think it's an international statement that we need to have hope for the future. We need to see that technology is progressing and that it's spinning off and helping us. Water purification is a good example. This new material, single crystal graphene, has shown in the last X months that it's a miracle material for water purification. If you have a sheet of this stuff, you just pour bad water on the top and everything's filtered out and you have good water below. And so instead of having huge processing plants doing water purification, which is patently impossible in much of the world, we, the people doing the production of this material, could, come up with a business to sell just sheets of this stuff. And then in villages all around the world, they could run it between trees or run it between, whatever, and purify their water. I mean, what a remarkable material if we can purify water with just having a sheet of this stuff. That changes the human condition. And so that's a spin-off of space elevators. Well, not really a spin-off, but anyway, but it's a spin-off of high technology being developed for more aggressive projects like buildings that are taller and space elevators and things like that. So I believe there'll be spin-offs and knowledge and information that comes out of the space program, just like it has in the past, that'll improve the condition of the human. So, and the international cooperation will be forced, I'm sorry, the wrong word, forced. Having international cooperation will force us to be closer together. And so that can only be good. I think that the international movement to the moon is a symbol that says humanity is taking a big step forward. Anyway, that's I'm an optimist and I'm very biased for this project, so you have to take it with a grain of salt. But I really believe that we need to go to the moon as a human race.
Yeah, definitely. I couldn't agree with you more. Well, Pete, I thank you so much for your time. I know we're considerably over maybe what you had planned on, but
my next appointment is Tuesday, December 3rd.
oh, fantastic. Well, is there anything that you wanted to talk about that we didn't get to?
No, I think I've explained the space elevators are the answer enough. But I really, truly recognize your quest as a valiant move out there. You really have to have somebody like you asking those questions. And then we come up with a statement to, something like to NASA, hey guys, you really have to get the word out that this is an important program in international cooperation, in development of technologies and spin-offs in, the human condition, et cetera, et cetera, et cetera. And so the only way to get that message to NASA is give them information or national leadership or, one thing that's really neat. Are you a member of the National Space Society? I hope, anyway.
Not only am I a member, but I founded a chapter here in North Houston.
Oh, good. Well, that's right. I saw that in your brief. Yes. Yeah. No, that's fantastic. So you'll be at ISDC in LA in May then.
I sure hope so. I sure
Yeah,
hope so. I mean, I was planning to be there in Dallas this year,
uh,
but that didn't
yeah,
quite work out.
that didn't work out. I was there. I already made reservations, and I forgot to cancel them. And the Marriott was nice and didn't give me any problem. But yeah, no, the excitement building for the Sheraton out there in May is really neat. We're going to have our International Space Elevator Conference the 2 days before the ISDC. So literally, if people want to come in and learn about space elevators, we'll have 2 days conference, and then we'll have participation in the ISDC. We've historically had a good role to support ISDC, and I help those guys with stuff, and so that should be fun. The point I was trying to make is the NSS is a good avenue into the political arena in Washington. And if you can get some really good data, like you get the 2,000 interviews, when you get to the point where you have a good set of data, passing that on to the proper people in the proper place, like the National Space Council, the NASA administrator, all that kind of stuff is important. I really can't undervalue what you're doing. It's important that we get that information to the right place saying, wake up, guys.
I know, because one of the biggest, well, one of the uh, benefits that's hyped a lot is inspiration, but it's difficult to say it's going to inspire people if they don't know about it.
Right. Yeah, I feel one of the big things about going back to the moon, forward to the moon. Going forward to the moon is the hope that it gives the young people. You go in and talk to classrooms and everything else, and you talk about all kinds of stuff, and then you say, "Oh, if you looked up at the moon lately," and they go, "Well, we're going back there." And they all go, "What?" Sixth graders, they don't know about this stuff. And so you explain that they're in the sixth grade now. If you give them 10 years to finish high school and finish college, they could be right in the middle of the movement going to the moon. They could literally walk on the moon. And, they all stop pretty fast when you say, you can walk on the moon. They say, what? They start getting it if you explain that after you finish school, we'll be in the middle of being on the moon and you could go walk on the moon. And that motivation, I think, is important. People kind of undervalue the motivation to our young people if we give them opportunities in the future that are a little different than their parents had, a little bit more challenging. And then they say, well, how do I get there? I say, well, the first thing is you excel at school. Don't quit school. Keep accelerating. And oh, by the way, you can go if you're a plumber and if you're a cook. We're going to need plumbers and cooks and everybody on the moon. So by the time you get there, it won't just be astronauts that are test pilots. So
Absolutely. We'll need people that are good with manipulating the bits and also manipulating the atoms. They need to be able to make things and
right,
fix things.
yeah, definitely. Yeah, I'm afraid I'm a failure at putting things together and stuff like that. I have trouble at home, so they probably won't hire me to be the fixer. But I can learn how to cook if I need to. But I'd like to go. I think Kathy and I would go in a heartbeat. There'd be no problem.
That'd be awesome. I'll have to plan on going to the Space Elevator Conference before the ISDC as well.
Oh, that's great. Okay, I'll put you on a little list and send you the invite and stuff as soon as we get the details. We're finalizing the details this month. The next board meeting will all approve. But we've approved. We're going to have the meeting there. We're going to set up in the Sheraton. We're going to buy a sponsor package at NSS and all the normal stuff we do when we're going to be there. So should be a fun thing.
Well, thank you so much, Pete.
Okay.
You have a good rest of your day. And if you know anybody else that'd be willing to talk to me, hopefully you'll send them my link.
Okay, will do. I think let me think about that a bit, and then we'll get you maybe one or two people to interview. That'd be great.
Well, thank
Okay,
you.
so thanks.